It needs like sound effects, I feel. It's kind of underwhelming, like, yes. Hey there, everybody. It's Thursday morning, 9 a.m., and you know what that means. It's time for OpenCV Live. We will get started in just a few moments here. I'm going to push the button on Zoom so Zoom folks can get in as well. There we go. Okay, it's going to be a fun one. We're going to learn some stuff today. Sit under the learning tree with our new friend, Ron Evans. We're going to learn about WebAssembly and Go and how Vision works with those things. As longtime viewers of the show know, I'm an old-time web developer. I still write CSS and HTML by hand, and I've been really interested in WebAssembly the last couple of years, but I have not messed with it much, and so this is going to be a great learning experience for me, and I hope for you too. Satya, how you doing today? Where are you joining us from?
From San Diego, California, and today is one of those like 5 days when it's not sunny. So
rare. And Ron, our guest, where are you coming to us from, Ron?
I am in from Asturias, Spain, the north coast of Spain.
Right on. And how are you doing today?
Oh, it's a beautiful day. The sun is out, and glad to be with you folks.
Yeah, it's a beautiful day in the neighborhood here on OpenCV Live. Please, I am coming to you from the friendly confines of OnBase Productions in beautiful downtown Niles, Michigan. This is my brother's photography and video studio. OnBase Productions, you can go to onbase.store to see all sorts of good stuff. For example, they're an official Field Notes distributor, my favorite brand of notebooks. I got the new ones in today. These are the set of 3 Fall Flowers 48-page memo books. You can find those at onbase.store, onbase.store. There's our pitch for in exchange for using the space.
I love those, by the way.
Oh, who doesn't love Field Notes? Field Notes are the jam. So yes, we'll get started in just a few moments. Please let us know where you're coming from. Post it in the chat wherever you're watching from. I see some folks finally getting in over on the YouTube and on Twitch. Good news on the Twitch front. We are now monetized on Twitch. I think we have to fill out the tax documents and we can start making a couple extra bucks over on Twitch. I'm really excited about that. So we've got YouTube, we've got Twitch. We'll continue branching out to the different platforms so long as people keep asking for them. But yeah, let us know where you're joining from the chat. I'm looking over on Zoom. We've got Richmond, Virginia over on Zoom. Love to see it. We've got Ottawa, Canada. Lovely London, UK. We've got India chiming in over on Zoom, the Indian contingent of OpenCV, the powerful India bloc. Let's check out LinkedIn over there.
Yeah, we are unable to see the chat.
Yeah, we need to get a good way to share the chat with the guests and stuff, but it's fine. I can deal with them. Anywho. I think it is about ready we're about ready to get started here. What do you think, Doc?
Yeah, let's get started.
Let's do it.
Hello, everybody. Welcome to OpenCV Live. And in today's episode, we have a very enterprising developer, Ron Evans, who's going to talk about WebAssembly and Go programming applied to computer vision. So he has built a lot of tools which make computer vision accessible for WebAssembly and Go programming language. So, but before we do that, we are going to, also with us is Phil Nelson, who is the Director of Content and Creative at OpenCV. He produces these shows, and if anything goes wrong, it is his fault. Hi, Phil.
Yes, that's right. Hello out there, everybody. It's me, it's PHI-LLIP. I am your co-host with the co-most, the second banana who is second to none. I'm also your plus one and only. You know, it's Mr. Nelson if you're nasty, but you can call me Phil. And I'm here to remind you of a few things we do on every single episode of this here program. The first of which is a giveaway to you out there in the audience. We are going to ask a trivia question in about 40 minutes after the presentation from our guest, Ron Evans. And the first person to answer that trivia question correctly will win the OpenCV University course of their choosing. We're also taking questions from you in the audience. You can ask those questions wherever you're watching. We are live on LinkedIn Live Video, YouTube, Twitch, probably Facebook, and some other places. If we're lucky, people are pirating the stream elsewhere. It's a sign of success, folks. But going back to OpenCV Live, going back to OpenCV University, we've got a big OpenCV University event happening right now. Satya, do you want to tell the folks about that as I bring it up on screen here?
Yeah, so we have this 100-day AI Mastery Challenge going on. This is, right there. So basically, we do these sale events once in a while. But the interesting thing about this sale is that, first of all, there's a 35% discount on all programs. And I would highly recommend the Computer Vision and Deep Learning Master Program, CVDL Master Program. And the best thing about this one is that it rewards people who are highly motivated. So if you not only have a 35% discount right now, but you also have something called the 100-day challenge. So if you actually enroll for our courses, you will get $100 off for every course you complete in the first 100 days. So we have roughly 100 days left in this year. So it's perfect, right? We encourage people to actually have a New Year's resolution, not on the New Year, but that completes on the New Year. So that this is perfect. You do this, you get $100 off for every course you complete between now and the end of the year. So amazing deal. Check it out. And if you're looking for a career in computer vision and AI, I would recommend the Computer Vision and Deep Learning Master Program. All of this comes with a 30-day, no questions asked, money-back guarantee. And so please enroll if you are interested in a career. And if you're thinking that, I'll start next year or something like that, think about what happened in the last 6 months or in the last 1 year. If you had been interested in computer vision and you did not start, time passes by, it is going to not stop for you. So if you have that burning desire right now, please go and enroll right away.
Yep, that's opencv.org/university. OpenCV is a nonprofit organization that puts out open source software, and as such, we depend on the support of our members and partners. We would like to give a big thank you at the top of the show here to ARM, Qualcomm, RunPod, Intrinsic, FutureWay, JetBrains, RoboFlow, Hackster.io, the official community platform of OpenCV, 7th Sense, Google Summer of Code, OpenMV, Orbic, Tangram Vision, Amped Software, Intuitivo, Rerun.io, the Edge AI and Vision Alliance, and Big Vision. Every company needs a big vision. I think that is enough of pre-show stuff.
All right.
Take it away. Ron, it's your show.
All right. Well, thank you so much for having me. So this is about OpenCV for Go and WebAssembly.
Mm-hmm.
And I am Dead Program. Some people call me Ron. Couple humans call me Dad, but that's not really important. all the internet places, I am Dead Program. And I am a technologist for hire. Get it? Technologist for hire. You can pay me fiat currency and I will produce code of unknown value. Hopefully a lot.
I mean, what is value really? I mean,
indeed. It's definitely in the eye of the beholder. So I have a small boutique consultancy called the Hybrid Group, where we create the software that makes your hardware work. Done projects for many companies over the years, but mostly the thing I'm here to talk about is open source. One project that we're very well known to be involved with is something called TinyGo, which is the Go compiler for small places. Lets you run Go on microcontrollers and also compile it to small WebAssembly modules. And GoCV, which is, in fact, mostly what I'm here talking about today, which are the Go wrappers for OpenCV. And of course, in the Go programming language. Go is a language created by Google originally and being used all over the world. It's pretty much, excuse me, the language of cloud computing. Things like Docker, Kubernetes, CoreOS, Ubuntu, Snap, and many other things are all created using Go. But we're very involved with bringing Go to embedded systems and computer vision. So GoCV is a pretty popular project on GitHub, 7,200 plus stars, 890 plus forks, 150 plus contributors. It's small change compared to the mothership of OpenCV, but not too bad for an open source project. So first of all, why you should use Go for computer vision. Now, if you do computer vision today, you're probably using Python. You might be using C++, but let me tell you why you might consider taking a look at Go. So Go is a language. It's very well known for its concurrency. Concurrency being doing more than one thing at the same time, not necessarily dividing a task into smaller tasks. That's parallelism. Concurrency is just doing multiple things at the same time. One thing about Go is Go right out of the box. It uses all of the cores on your multi-core processor. So helps do things in a concurrent way. Another is Go's portability. Go, the language, runs equally on Linux, on Windows, on Mac OS, on embedded systems. So same code, compile multiple times, but same code. And then performance, again, because code needs to be concurrent in order to use the maximum capacity of modern processors. This really helps Go achieve very, very high levels of performance. That's one reason why a lot of the networking stack that's in use today for, as I mentioned, Kubernetes, Envoy, proxy, a lot of other software. So Go's performance is great. As I mentioned, runs on Linux, Mac OS, and Windows. So how computer vision works? Well, most of the people watching this show probably already know, but I've invited a few who are just getting started. So in OpenCV, of course, the base unit of data is the mat. So it's a matrix of data of some sort. And I like to think about it like a Lego plate. And then, of course, most of the time, though, we're interested in talking about color images. For example, here's an RGB mat. Actually, OpenCV usually stores them as BGR, but that's not important right now. Let's just say RGB. And so you can see the bytes, in this case, for the red, the green, and the blue are sort of stacked next to each other for each pixel in our mat. And so we can sort of go on with this Lego metaphor, but this is, you get the sort of idea. Now, how OpenCV/GoCV work, OpenCV itself is divided into modules. And these different modules handle different areas of functionality. So GoCV maps directly to OpenCV. It is a wrapper. It does not try to invent a new programming paradigm. That's something else that comes later in this show. But GoCV just tries to do basically the exact same things in the same way that OpenCV does. That way, when you're looking at documentation, scanning the internet, using some type of generative tool, you're a lot more likely that the code you get is actually the code you want and that maybe actually works. So let's see the hello world of video in Go. So this is a simple Go program. In Go, we start out with a package main. That's our main, the main entry point for our program. We use the import keyword, very similar to Python. In this case, we're going to import the GoCV package. And then we have our function main, our main function. So the first thing we're going to do is call GoCV open video capture. And we're going to pass it 0, meaning camera 0. And that will return a webcam and also an error that we're just going to choose to ignore right now. So then we'll open a new window. Again, same thing you've generally seen if you use Python or C++ with OpenCV. We're going to create a new mat for the image. And then in Go, there's only one way to loop. It's for. In this case, for with no parameters means forever. So forever, read the image from the red webcam, show it, and then wait key for 1 millisecond to give us a chance to terminate the program. So this is just your basic hello world. So let's go and see if we can actually run this. So if I say make hello.
You might, Ron, do me a favor and bump up your terminal font size a little bit.
Sure.
Next time you show it on there. Thank you.
So this is that program that we just saw running on my computer using the GUI interface that's part of OpenCV being called by GoCV. So it's just your basic hello, nothing special. Let me bump up the font size here. Is that a little better?
Yeah, much better.
Okay, great. All right. So let's take a look at something a little more sophisticated. Real-time object detection using YOLO. This is another one of these canonical, like, you must show this demo if you are talking about computer vision. Like, sorry, I didn't make this up. You know, I'm just following the herd. So again, for those who are not initiated, which is probably most of the planet, YOLO stands for you only look once, and it's of a category of deep neural networks that are called convolutional neural networks. And this is sort of a idealized convolutional network that, imagine these are the pixels of your image, and by running calculations through different nodes in this network, we can hopefully figure out exactly what something is. This is your typical object tracking or face recognition. Pretty much everything uses these convolutional neural networks. So we're going to use the DNN module, which is a really important part of OpenCV. And we're going to use CUDA. There's really great CUDA support in OpenCV, and GoCV lets you use that. So let's take a look at this bit of code. Let me bump this up as well, because it's kind of small. All right. Can you see this okay?
Yeah, it's a little bit larger would be better.
Let's go big.
Okay, yeah, perfect.
So again, this is your basic Go program. The entry point is a package main. We're going to import the FUMT package. FUMT, or FMT, is one of the Go standard packages to do formatting of text. The Go standard image package, the Go standard image color package, and operating system package, OS. And then, of course, GoCV. And this, again, is your typical program. We look at the command line arguments because we want to be able to pass in which video source to use for if you have multiple cameras, as I do, which YOLO model file, which Onyx file to load, and then which backend and device to use if we want to use the CPU or if we want to try to use hardware acceleration with CUDA or Vulkan or something else. So we parse these arguments in typical Go fashion. In this case, our default is the net backend default and the net target CPU, but we'll override these for the demo. And then we open our capture device, just like the hello. This time we'll look at the error. And if there is one, we'll exit the program. If not, then in Go, there's a keyword defer. Defer means when this function exits, do this thing, call this function. So this says, when we exit the main function, close the webcam. That way, at any point where the function exits, we make sure that we close the webcam before we leave the program. It's one of those nice things in Go. So then we open a new window. Again, defer closing the window. Create a new mat to store our image. And then now we're going to open our DNN object tracking model using the readNet from Onyx function, which again is a wrapper around the OpenCV DNN module. We want to close that neural network when we're done. And then we'll set the backend for that network so that we can use our CUDA acceleration if we want. So then this function takes a look at the names that could be classified. This particular network is going to, whatever it sees, it's going to try to classify what type of object it is. A person, a phone, whatever, of the objects it knows about. So then our loop here is we read, just like the hello program, we read from the webcam. Then we call the detect function, passing it that neural network, the image, and then what the possible output names are. So if we look at that function, again, it looks very much like the Python or the C++ examples in the OpenCV samples, this is, again, same type of API, just Go. So in this case, we're going to have our image to blob. In order to use an image with a deep neural network, we have to convert it into a blob format, which is basically strips the red, the green, and the blue into separate ranges of data, typically. That's the most common pattern. So then we're going to convert it to the blob. We'll set that to the input of the neural network. That way the neural network knows this is the image we want to try to process. Then we pass it through the network. And then with those resulting probabilities of what we think it might be, person, gorilla, etc., we then take and sort that out into the boxes where the things it found are, the confidences, meaning how sure is the neural network that it is that thing. And then, again, we convert those to the rectangles and display that on the screen using, again, the typical GoCV style, OpenCV style, drawing a rectangle that is the size of each of those boxes, putting some text on it, identifying what it thought it saw. So this is very much like any of the code that you've ever seen. So let's actually go run it. So this is running the YOLO 8S model. And let's see, a person. I've got too much stuff in the way. I guess a phone.
Many such cases. Many such cases. Yeah. It's YOLOing. Oh, it's it's traffic lighting. Yeah. Okay.
So
yeah.
This is your basic canonical. You've seen this demo a million times. Now you've seen it in Go. All right. So maybe a short pause for some questions, just because I've shown you a lot of things all at once, but it seems like a good place to.
Yeah, sure. We can pause here for a moment, and I'll bring up a couple of ones that we have had in the chat here. Let me go ahead and hide your screen share, and I'll bring us back. Satya. And here's me for some reason. Yeah, over in the chat here, we've got a couple from YouTube here. We just, Manish asks, where do you find details of what packages to import or features are available in each for these Go programs?
Well, there's a lot of standard packages that are part of the Go standard library. Go is very much a batteries included language, and a lot of the capabilities that you would normally need to write any type of, garden variety software are already in the Go standard library. There's also a very large number of packages out in the world. There's a central index of packages called the that you can find that basically looks through GitHub for any Go packages. Oh, this is an important thing to mention. Go by default, it uses Git repositories as its source of packages. So you don't have to package something separately and push it like you do with Python. C++, there's no such thing. Just good luck. Maybe there's Debian packages or Linux packages or something, but there's not like a particular way. Windows, there's Scoop and Chocolate Tea and a couple of other package management systems, but these are generally for binaries. If you're writing Go code, if you say go get, which gets a package, and you provide a GitHub URL, then it will just download the code and execute it in your application from there. So it's quite easy to find them. And then the Go docs is a standard documentation format of how you would document, similar to PyDocs or other things that you've seen in other languages. In this case, there's a daemon that goes through and all of the GitHub repositories that are in fact Go packages. It then creates documentation files automatically, all indexed through a single website. So that's one reason why the Go ecosystem, it's not really centralized, but it's centrally indexed and organized. So that makes it a lot easier if you're trying to figure out, how do I do something, to go out and try to find some code that already does it, hopefully. I mean, that's part of open source.
Yeah, thanks for that. Got another one here from Zoom. I'll bring up on the screen. How does Go performance compare with, say, OpenCV Python?
It's really not a fair fight. Python is an interpreted language. Go is a compiled language. Go compiles to native code, native binary code. It's not like Java, where it's an intermediary bytecode. It's actually native code. So that's one thing. Also, as I think I had mentioned early on, Go's concurrency is one of its big strengths. In Go, there is, if you say Go, the word Go, and then a function, that function automatically executes as a Go routine, which you might think about kind of like a green thread. So it's very easy to start these Go routines up to do different work, and then you coordinate them using what are known as channels. So channels are the implementation of Tony Hoare's communicating sequential processes, CSP paradigm. So it's a really, in a nutshell, it says share memory by communicating, don't communicate by sharing memory. And this is one reason why it's a lot easier to write fault-tolerant software in Go. So in short, Python's a great language. It's, got a lot of nice things about the syntax that make it easy to use, but the performance of Python just really has nothing. It's orders of magnitude slower than compiled Go code.
Yeah. I like to say that Python is not it's not really a great language. It is an easy language. And it got adopted by the machine learning community. And that's, it's a historical thing, in my opinion, that, it's a decent language, right? But a lot of things are being retrofitted. And of course, it is, it's not a compiled language. The benefit it has is that all the libraries that we use underneath Python, they are usually C++ compiled libraries. So the performance hit is not obvious, right? You don't see any performance hit because underneath it is just using C++. But if you were to write native Python code, then that can become very, very expensive, right? Very computationally expensive.
Well, first, before I sound like I'm dissing Python, I write a lot of Python.
Yeah.
A lot. I do a lot of model fine tuning.
Yeah.
So if you're doing anything serious in machine learning and you're not using Python, I'm wondering if you're actually doing anything. I mean, it's just, it is.
So I mean,
no question. But let me just it is true that a lot of Python that you use is actually calling some compiled code underneath, but it's still essentially single-threaded code.
Yeah.
So, for example, one of the early users of GoCV, when we first came out with it, they were just so excited because basically it was this. We had this Python program that had to process like 1 million images, and it was going to take like 3 weeks. So I rewrote it in GoCV using Go channels, and it just finished now after 6 hours. Now, look, that was not fair, okay? One was concurrent, the other was single-threaded.
Yeah.
But trying to actually do this in Python can be quite tricky.
Yeah.
And doing it in Go is, it's part of Go only has 22 keywords. It's a very stripped-down language. So, I would definitely say figure out how to get it to work maybe in Python and then make it work well and production level in Go. Yeah. That's sort of been my pattern.
That is one of, I think, the biggest strengths of Python is how easy it is to stand up something that's good enough. You know, like just to be like, okay, this is what I want to do. This is how I want to do it. And you can just really quickly build that scaffolding and get something up and have like a usable, visible demo, or even, you know, a service or something up just like very, very quickly and, you know, relatively robust. Obviously, yeah, the performance is not going to be as good as a compiled language, because it's impossible for it to be. But I think the big benefit, yeah, and then part of why Python has been adopted so widely in data science and in CV and AI is because of that. Everyone's working so quickly that they just need it. It doesn't need to be super fast right away. It needs to be there right away. It needs to exist right away.
Well, Jupyter notebooks, absolutely.
Yeah.
I mean, Jupyter notebooks
for shareability. Oh wow, yeah.
Wonderful tool.
Yeah.
Now, this might be a great time to throw out an aside. Not my project, but there's an amazing project coming out of Google Research called GoMLX. Has nothing to do with the Apple MLX, poorly named, I guess, but it's actually a whole set of machine learning tooling written in Go to do like the equivalent of like PyTorch, transformers, a bunch of other stuff coming from Hugging Face, all written in Go. You know, download files and convert them to Onyx format in Go, like all these things. Not my project, but one that I'm becoming more and more aware of, and I think is really tremendous work. So go check that out. Go MLX.
Yeah, we'll add that to the show notes there, the link, so folks can check it out. I think, yeah, Ron, you ready to continue with presenting here? Let's do that.
Let's go. Let us go on.
All
right. So now let's talk about WebAssembly. And for that, I'm going to talk mostly about a project that I've been doing almost 1 year now called wasmVision. So first of all, computer vision using WebAssembly. First of all, what even is WebAssembly? All right. So WebAssembly is a standard for creating, well, first of all, it comes from the consortium called the Bytecode Alliance, which has basically every big co you've ever heard of and a bunch more you haven't, you know, the usual suspects, Microsoft, Amazon, Apple, etc. So WebAssembly is essentially a bytecode standard for writing programs which execute on an idealized processor, like a virtual processor. It's very much fulfilling the promise of what Java was trying to do with something like the Java runtime environment. Also, it defines interfaces that these WebAssembly programs can then use to communicate with their host environment. It's very important to mention that WebAssembly programs, guest programs, execute in an entirely sandbox environment, so they do not have any direct access to anything. Everything that they do has to go through the runtime in their host. So WebAssembly in the browser, you are already using this today, my friends. If you use anything from Google, anywhere, on your phone, on the web, everything like Google Sheets, it's all written in WebAssembly. So it's already here. It's arrived. So, but calling it WebAssembly was maybe not the best idea, only because it's got a lot of uses not in the browser. But let's stick with the browser for a brief moment. So your typical WebAssembly browser architecture, in your browser, you've got some type of JavaScript runtime, typically, let's just say V8. You've got your HTML page. It loads some JavaScript, and then your JavaScript can call some code which loads inside of the browser's WebAssembly engine a WebAssembly file that it then can start to execute. So an example of that also uses TinyGo, which lets you compile code for the WebAssembly target, is Conway's Game of Life in WebAssembly. So this was written by my friend and collaborator, Alessandro Cifani. He wrote Conway's Game of Life in Go and TinyGo.
I think you're legally required to do a Conway's Game of Life implementation for any new language.
I have a whole talk about that, which is nothing but a series of Conway's Games of Life in different, more radical forms.
Oh wow!
But that's a whole separate thing. Anyway, though, this is just kind of giving WebAssembly executes very quickly and has a lot of capabilities in the browser.
You got to remember, some of our audience are pretty young. We're going to have to explain to them Conway's Game of Life later in the show, but continue.
Yes. So then Wasm in the cloud. So you already might be using Wasm in the cloud if you use a lot of different services. Fermyon Spin, which is a platform for WebAssembly serverless functions, which actually you can now deploy even to Akamai's cloud. Cosmonic with their Wasm cloud, which again, same idea, you can create WebAssembly serverless applications. And Fastly, who basically is running, half the internet, I think, give or take. Nobody knows who Fastly is until Fastly went down a couple of years ago for like a couple hours, and everyone's like, "Who's Fastly?" So Fastly's cloud development kit uses WebAssembly, and is actually worked on by a couple of contributors to TinyGo, who are full-time Fastly people. So they use something called the WebAssembly System Interface, or WASI. And so the WASI architecture, an application that is compiled for WASI is able to use some particular interfaces. There's a preview 1 and there's also a preview 2, now a preview 3. And so your program that you write can then call those interfaces inside of whatever WebAssembly runtime, whether that's wasmTime, which is written in Rust from the Bytecode Alliance. That's the one that's used in Fermyon Spin and the Cosmonic offering. Was0, which is a WebAssembly runtime written entirely in Go, which a lot of people are using to extend Kubernetes with WebAssembly, or network proxies like Envoy. And then what you can do is then access host interfaces like the networking interface or the file system indirectly, so that if you want to give people the ability to install separate programs without the risk of crashing or bringing down the environment or getting access to resources that they shouldn't have, that's very much what this WASI architecture is about. And then that brings up WebAssembly on embedded. That's my jam. Okay, that's my thing. But I live for that. And that's where we get into the Wasm unknown, which is you define your own interfaces. It's just, you might think of it as raw WebAssembly with no particular host interface defined. So this is great if what you want to do is create industrial computer vision systems. Why? They're typically running on embedded Linux devices. So they're in a factory or a retail store somewhere, some type of edge computing device, like an on-prem server or a factory floor data collection server, or even a cloud if you want to do some type of mass processing of videos or images in some type of form. This is another industrial type application. And they're being used, computer vision is already being used right now in agriculture, transportation, energy, security, manufacturing, retail. Those are just some of the applications that we targeted when I used to work at Intel with OpenCV based and OpenVINO and such. So one thing you notice as a practitioner, perhaps, is that a lot of computer vision applications have the same basic structure, right? But there's a lot of different parts to integrate depending if it's a factory environment and you have high-end industrial sensors, or if it's a remote environment and everything has to be battery operated at low power because it has to charge solar cells during the day so it can operate 24 hours. Hard to run on different kinds of machines. You generally, block 1 of the factory is going to use one generation of embedded hardware, and the next block will use a different one. And then the extensions to the first block will use yet another one, and so on. So you end up with a very heterogeneous environment, even in a single company. Very hard to update. Some industrial companies, I won't mention by name, but their whole business model is they just sell you a new one. Right? It's not user updatable.
Turns out.
Yeah. That's a whole separate rant that I will only do in a bar with a drink in my hand.
Right.
The guilty shall remain guilty.
They know what they did.
Yeah, that's their business model. But and again, these applications, there's some need for customization that's generally pretty sophisticated. It's not just a few checkboxes. There's usually some type of logic that the computer vision has to have in order to take action immediately, whether that's turn off the machine so it doesn't grind up the operators into small bits or something. Right? So that was why I created wasmVision. So the idea with wasmVision was to help you get going with computer vision using WebAssembly to do the main things you would ever do with these types of systems: capture video, process it, save it, stream it, or do something with its data. And so wasmVision is an engine. It comes with a command line interface that you execute, and then the engine itself, and then the processors. The processors are the things you write with WebAssembly. All right, so the engine itself is written in Go. That way we can use all of the performance and all of the concurrency and the things that Go can do. And of course, it takes and brings in OpenCV, FFmpeg, GStreamer. This is all being controlled by GoCV.
Yeah, all great choices.
Shout out to the homies at FFmpeg.
Oh yeah. None of this could exist without the great work of many others. WAS0, which is a WebAssembly runtime written entirely in Go, and all of this combined into a single statically linked binary with no external dependencies on Linux with no GPU. I have to put in that caveat. If you want to run with CUDA, then you will need to bring in some external libraries. If you want to run on Mac OS, you're going to need to bring in some external libraries. On Windows, it depends. Can't give you a simple answer, but as of right now, so this makes it a lot easier to deploy and have this. Again, it's a very large binary, but it is a single binary, and it can execute in the Docker container as well as just natively on your embedded Linux. So let's take a quick look at the wasmVision architecture. We've got the engine. We've got our ability to capture, excuse me, pass our frames into the WebAssembly runtime, and then our processors get these frames and can call into OpenCV modules using the FFmpeg and GStreamer extensions that are part of OpenCV to do things like processing files, streaming video, all sorts of other curious and interesting things and capabilities that these tools have. So wasmVision processors can be written using Go with TinyGo, or with Rust, or with C. Nice. So bonus, you're actually going to get to see some Rust code in a minute. So this is all thanks to something called wasmCV. So wasmCV is another open source interface that was created by the Hybrid Group, my consultancy, and friends who are interested in this. And the idea is that it creates WebAssembly interfaces for computer vision. These interfaces, by the way, are based on the interfaces that OpenCV already has and uses. So if you use OpenCV, or if you've ever used OpenCV, then these interfaces are going to be probably very familiar to you. So they're defined using something called WIT. WIT is the WebAssembly interface type. It's a interface definition language, and it's part of what's known as the WebAssembly component model, which is a future model for interoperability between WebAssembly components so that they can call each other directly without going through the host and have access to other resources. But that's not out yet. But however, wasmVision is not using the WASM component model. It is using WIT to generate client interface wrappers and documentation, but does not require the component model. That makes it a lot easier to have backward compatibility with those who have been doing WebAssembly compilation with mostly with C. So we also are using a package called Wipes, created by my friend Graham at Orsinium Labs. Wipes is the interface layer on the host side that's able to get these calls from the WebAssembly modules. We'll see this in a minute. So how WIT works. WIT defines interfaces. It's got basic types, ints, strings, floats. It's got records. Records are what you might consider types in C or a struct. And it's also got resources. Resources are essentially a pointer to a resource which is controlled by the host. So in other words, the WebAssembly program does not have direct access to it. It has to go through the resource. Let's take a look at an actual example so it's not quite so abstract. So this is the world.wit file for wasmCV. And you can see that we import into our world the mat type and the DNN and some other ones. Let's take a look at what some of those are. If we look at mat is an interface, and we see a lot of, it happens to be a resource because it's entirely controlled on the host. The WebAssembly modules can only call it remotely from inside the sandbox. And that way they can't crash the machine or do other nasty things. And then you see a lot of functions which are so similar to the OpenCV functions that in fact, we have links to the docs for many of them because, of course, if you know OpenCV, you should be able to use wasmCV. So let's actually, so everything is generated from the WIT files, all of the wrappers for all the different languages. If we look at even the docs, so if we look at the docs for mat, we see the same things that we were seeing defined in that interface, the basic functions that you're used to using, getting regions, copying mats from one to another, getting individual pixels, and so on. So again, OpenCV really is the standard that has been set. This is just using these same principles, but applying it to WebAssembly. So let's take a look at some wasmVision processors, first in Go. So in Go, we're going to use package wasmCV, same as, to import it. We generated everything with a tool from the Bytecode Alliance called WIT-BindGen Go, which is able to take those WIT files and create Go wrappers for us, so we don't have to worry about the minutia of how to call between these two environments. And to compile it, we use the tinygo build command. We say that our output is blur.wasm, meaning a wasm module. Our target is wasm unknown, because it's basically raw wasm, no specific interface, because we're only using the wasmCV interfaces, and then no debug information. That way it's very small and minimal. Let's take a quick look at some of the code. How are we doing on time? Oh, we got to keep moving. We got it. So this is a blur processor. So we see we import, it's like any other Go code you've seen, except now we're importing wasmcv.org wasmcv-cv or wasmcv mat. And every wasmVision processor has got the same pattern. It has a single function that is called process, and that takes a single parameter, which is the image of the mat that it should process. And it returns a single thing, which is the mat that it's done the processing on. So in this case, we're going to call the blur function, taking that input mat, using a kernel of 25 by 25, and then the result, the output mat. If it's empty, we're just going to display an error to our log and then return the original image. But if it actually worked, we'll return the blurred image. All right, so pretty simple stuff. Let's see it work. So if I say make blur. Now, one thing about wasmVision is by default, it's got built-in MJPEG streaming. So this is just streaming to my browser window in another pane, just because, you always want to do this. You can turn it off. There is a flag. But so there's me, and I am blurry in Go. All right. Off to a fine start.
POV, your glasses got fogged up.
Yeah. So now let's look at the same thing in Rust. So in Rust, we use crates. So of course we have a crate wasmCV. That's how you bring in wasmCV. And the generating of the wrappers was done using WebAssembly, which is another tool from the Bytecode Alliance that is able to generate Rust and C wrappers from WIP files. In order to build it, in Rust, we use the cargo command. We say cargo build. Our target is wasm32-unknown unknown. And we're going to build a release build, which in Rust gets rid of the debug information and pretty much everything else. If we take a look at the code, we can see in Rust, the code's a little bit longer, but we use wasmCV. Use is the equivalent of import or require. And we have our single function entry point process. It takes a single parameter, a mat, and it returns a mat. So now in Rust, we cannot simply change variables. Rust is an immutable language. So we have to make a clone of that mat in order to actually blur it. We cannot blur the original code. That's just the thing Rust does not allow you to do as part of its type safety checking. But otherwise, it's the same thing. We blur that mat, the copy of the mat, same kernel. In Rust, there is a function called match. This takes a look at that result and very basically automatically for us, if there was no error, just return it. And if there was an error, log the error and return the original mat. So it's the same thing, but this is a very nice little Rust pattern. So let's go and let's take a look at the Rust processor in. So if we say make blur rs, it runs that processor, and I'm still blurry. Amazing. As if it was doing the same thing.
Do not adjust your television set.
So last but not least, C. So our C processors bring in C. We include wasmCV/imports.header. The wrappers were generated again with WebAssembly. And to compile it, we just have this very simple little command line.
Right.
Using Clang. Now, to be fair, okay, both TinyGo and Rust were doing all of this same stuff under the hood for you. All right. It's just you didn't have to see it. Now, C is a language that no one's grandfather got fired for choosing in their original project. Say a lot of younger people. And certainly, but there's a lot of industrial companies that want to use C because they already have a lot of C code. And so maybe they should look at a type safe language, but they can. But right now they got to do something about this computer vision problem and deploying it to their factory. So
I think Richie or somebody said C has the the portability of assembly language and also its convenience.
Yes. Well,
something like that. I'm paraphrasing.
Yeah, that sounds about right. So the same blur program, again, we include wasmCV imports. We have a single function, which is our process function. We pass it an image, which in this case is a wasmCV mat own mat, meaning it's a mat that we can change because C does not have the same borrow checking that Rust does. So it's just like, oh yeah, change the input, no problem. Our kernel, same size. Our output mat declared on the stack, so we have a place to put it. We call our wasmCV CV blur function, passing it that image. And if it works, or if it has an error, we return the original image. Otherwise, we return the output. So same thing, but just very C. And of course, as you might expect, if we make blur C, it still is me and I'm blurry. Cool. Amazing. So it all does actually work. Now, we're running out of time, so I don't have time to show you all of the demos, but let me jump forward to...
We can go 10 minutes over if you want to show a few.
Okay, great. So let's take a look at a couple of the processors that are more interesting. So one thing about processors is they provide basic building blocks for computer vision applications. They can be chained together, right? So you can take the output from one processor and put it as the input to the next one. And you can create your own processors, of course. I mean, again, this is all open source, all licensed appropriately for you to use for commercial purposes. Good luck. May the odds be ever in your favor, my friends. So let's take a quick tour of a couple that are included. One of my favorites is ASCII-Fi. So ASCII-Fi takes and
I know this one. I love it.
yeah, proves that you are in fact living in the matrix. So same thing we've ever seen in the other processors. Same entry point. We take our image. In this case, we're going to do some stuff to the terminal. We're going to send these escape characters, which start with a blank screen. We'll resize that original image. Then we call this image to ASCII function. This is kind of a cool little function that basically takes that image and then looks at its pixels and then converts each of these resized pixels to one of these characters. That way we get the appropriate text effect. All right. So, and then, oh, I probably should have left the other one up, but let's go back. There we go. So then we take that resized image, we output it both to the terminal, and we also display it into our stream. That way, if what I really want to do is put up a live stream of my environment and always be ASCII-fied, here's your code. You can already do it today. So let's see this work. All right, here I am. I'm sitting kind of close to the camera. It's my second camera. But yes, and of course, as I promised, we can also be ASCII-fied on the internet.
Oh, very cool.
Yeah. Are you in there?
Yeah.
So I have actually, I just realized I need to adjust it so that it's properly centered. That's why I'm a little twisted when I lean to one side. But
Hey, it just adds to the effect. It looks good.
yeah, no,
It looks like it's ASCII-fying like a composite video signal.
yeah, exactly. If you don't know what that is, you're lucky. You know.
Or young.
Or both.
Yes, or both. You're luckily young. So wasmVision has its own little platform of some important features you might need, like logging. We already saw that. Configuration. You can make HTTP calls to external services, and it has a data store. So let's see a demo that I like to, of this all put together. I like to call it Creative Captions. So Creative Captions is a live caption generation with an artistic flair. So the pipeline we're going to capture, we're going to use the Ollama wasmVision processor to call a vision language model. Then the style transfer wasm to do real-time style transfer. And then we're going to display captions on that output. All right. So in order to do this, instead of having a single massive command line, we can use TOML or YAML files. YAML is the file you use if you like to configure your clusters with Kubernetes. So that's one reason we support that as well. So we see here, our destination is port 8080 for our MJPEG stream. We're going to enable CUDA. And our pipeline is going to be first the Ollama wasm, then style transfer, then captions. And our configuration, the Ollama model we're going to use is the QWinds Nano Lava, which is a quantized version of the Lava vision language model. And we'll also put some configuration in for the caption to adjust its line height and size. Models download equals true. wasmVision can download the models for you that it needs if they're well-known models from Hugging Face. Kudos to the OpenCV team, by the way, for moving all the models to Hugging Face recently. Thank you very much. So the Ollama processor, what it does is it gets its input frame, then it uses the HTTP package that's part of wasmVision to make an external call to a separate Ollama server, which is running also on my machine, running the vision language model. And then with the results of that, it stores it to the data store. Why do we do that? Well, I'll show you in a minute. Let's take a quick look at some code. So again, same as all the other processors, we get our image mat. We load the configuration values I was just showing you from that file. And then we only do this every 5 seconds because we're running this locally and they can't keep up. Plus, how many captions can you read in 5 seconds? So we take the data that we got and we pass that image to the generate function that's in the Ollama server. And then it returns that caption and we store that to the processor under the caption. That way we can display it downstream and then we exit. Okay. The style transfer processor, you've seen fast neural style transfer before. It's one of the models that's supported in OpenCV. So this is just making calls directly through the DNN interface in order to do the rapid style transfer. That code is a bit simpler, or actually, sorry, a little bit more complicated, I should say, because we have to take and process the image, convert it to a blob, just like we did for the YOLO network, slightly different format, feed that into our network, pass it through our forward pass, and then taking that data back, we then use the results to draw a new image using the modified style, and then resize it back to the original size so we can draw it, right? So that creates the style transfer. Then last is the captions. Its job is the easiest. It takes the captions data for each frame that was stored from the Ollama and then draws it on the screen into the mat. So again, we take and we get the image we're going to draw it on. We get our data store so we can get the caption data. Then using that, we modify the text a little bit so it will hopefully fit on our screen. And then the last step is, wait, where is it? Here we go. We put it using cv.putText, we draw it on to the mat. And so then it'll be displayed. So that's the full architecture all put together. Ollama getting the data, the style transfer modifying the image, and then the captions drawing the text on there. So let's see this actually work. So first of all, let me make sure I've got Ollama running. Okay, yes. So now let's make captions. Not seeing anything showing up.
Brave live demo strikes again.
I hear my fan on. Even through my headphones, I hear the fan. That means it's doing something. Oh, there we go. Okay. A man who appears to be old. Okay, obviously this machine, this machine learning model is
man being negged by the Ollama API. Damn.
I mean, how rude.
Rude.
Headphones are connected to his ears.
Thank God, not wearing on his eyes.
Well, anyway.
Isn't technology amazing?
It is. It is. So we're pretty much out of time. Or can I show you one last demo? Or do we want to have time for questions?
Let's go for if you could wait, we can do we do this giveaway.
Yeah, we'll do our trivia giveaway here real quick, and then we can do some more demos. I think this has been a lot of fun, so we can keep going with it in a sec.
Cool.
I'll drop you off. I'll drop off your screen share here for a sec. And,
I see why. Ollama is not running in with my GPU. That's my problem.
That makes sense. Yeah, it's expensive. I'm going to go ahead and maximize myself here and do our trivia giveaway. Hey, folks, so one of the things we do here on OpenCV Live every single episode is a giveaway to you in the audience. I'm about to ask a trivia question based on the presentation here by our illustrious guest, Ron Evans. And the very first person to answer that question correctly in the chat will win the OpenCV University course of their choosing. You can see what courses are on offer by going to opencv.org/university. Even if you don't win today, check out OpenCVU. Maybe invest in yourself, invest in your career. We've got currently a 100-day AI mastery sale going on right now. You can take advantage of the big savings on OpenCV University courses, even if you don't win our giveaway here today. That's opencv.org/university. Today's episode of OpenCV Live is also brought to you by OnBase Productions, our gracious hosts here on today's episode. You can see behind me here the friendly confines of OnBase Productions. You can find their online store where they sell cool stuff such as Field Notes, my personal favorite notebook of choice right here. They've got the new ones here. You can find them over at onbase.store. I'll give you another QR code here. Scan that, check out the newest field notes available here at OnBase Productions. If you have won in the last couple of months, please do not answer today's trivia question and give someone else a chance to win. Also, if you are answering on Zoom, please make sure that your chat messages are set to go to everyone and not just hosts and panelists. So I'm going to go ahead and make sure I have all the chats visible before I ask the questions. Okay. So I have a feeling you guys are just going to like totally nail me on this one. But let's find out. Earlier in the show, we showed a classic 0-player game in WebAssembly. What is the name of that classic computer science program? Oh, you're so close, Irving. Right. You're so close, Irving. Ah, there we go. I see Flavia on Zoom just before Greg Baker on Twitch, like 5 seconds before Greg Baker on Twitch. Correct answers I would have accepted would have been Conway's Game of Life, or simply Life, because it was also released under that name and various things. Greg Baker on Twitch, super close, answered Life. But number one here was Flavia in Zoom answering Conway's Game of Life.
The original Scientific American, where they wrote about it, they just called it Life, just because.
There we go.
As I recall.
Sense. Yeah. All right. So let me turn off my screen share here. Sorry, I fat fingered the button there.
Yeah, it's also fascinating because what it demonstrates, right? Complexity originating from very simple rules, right? Local rules creating global patterns, so to speak, right? Very, very interesting.
Yeah, definitely. So Flavia, please send one email to me. That's phil@opencv.org with the OpenCV University course you would like. You can find out what courses are on offer by going to opencv.org/university. I think we can now continue with demos if you're ready, Ron.
Yeah, actually, if you jump back over,
there we go.
Restarted.
Oh yeah, look at that.
Oh, nice.
Very cool.
Works a lot better with the GPU. I'm telling you.
Yeah, very cool.
Oh, nice.
So this is all running on my local machine. It's using both Olama running that vision language model. Vision language models, again, are computer vision model or machine learning models, which combine both some type of convolutional neural network for processing images, along with some type of transformer in order to then take that visual data and turn it into some type of text. So anyway, this is also then using the fast neural style transfer. And let's see how much of the GPU it's using. It's using only about 25% of my memory, so that's pretty good. I could be doing so much more. Yeah. All right.
Yeah. If you're not redlining it, what are you even doing?
Yeah. No, that was the giveaway. When the fan kicked on right away, I'm like, no, there's no way it's the GPU yet. Right. The fan is way louder. All right. So let me show you my last demo. Video drone. So it's a flight control station that uses facial tracking with a machine learning model. I've got a DJI Tello drone, which is a toy drone I often take with me, a DualShock 4 joystick that I appropriated from one of my children. And so let's take a quick look at the hardware. Of course, to do that, let's actually use wasmVision itself. Just because, that's how.
Why not?
I'm so meta. All right. So that's my other camera. So this is the drone. It's made by a company called Rise, but that was bought by DJI a few years ago. It has both a high definition camera on the front as well as a lower definition bottom facing camera for the optical flow algorithm that it uses to auto stabilize itself. So, this is my
do you
joystick.
have access to the bottom camera for, or it uses it for stabilization, so you don't have access to the frames, or do they give you access to the frames?
So, fun fact, that is actually used internally on the drone for through its Mobidius neural compute chip, which is actually the brains of it. And that was some of the stuff I did some work on, helped out a bit at Intel. So, but you don't have direct access through the default firmware to it.
So not the firmware. I was thinking about the actual frame.
Just the frames, right?
Yeah, the firmware that's on it does not give you access to the bottom-facing frame.
Got it.
Not on this drone. And I don't have that many of them left to try flashing any more pirate firmware. So, this demo I'm going to use GoBot. So GoBot is a physical computing framework written in Go that supports many different kinds of hardware. That was I was the founder of that project, but now I am no longer its main maintainer. The wonderful Thomas Kohler does that. So thank you, Thomas. And so we're going to use the UNet face detection model, which is one of the high-speed, cool facial detection models that's built-in support in OpenCV. Facial detection in general, and the UNet in particular, it works very well because it sort of narrows it down from a large number of possibilities to a smaller ones in a number of series of passes. That way, the amount of computation required is considerably less, so it takes a lot less wattage. So video drone, the drone itself, I'm going to fly with the joystick and a program that'll do its flight control. Make sure the thing is still on. Then the video stream, which comes from it, we're going to process through wasmVision, and we're going to take that, and we're going to use 3 different processors. We're going to use the facial detection YN processor, the face counter, which automatically counts the number of faces and stores it to any of the supported data stores, and then face blur. That way we blur the faces, that, privacy and all that. I know you might not, with all the bad things people say about facial detection these days, that it has some good purposes if privacy is actually thought about in this part of its architectural design. That's why you want to do the processing on the edge. That way that data never leaves the edge machine. All right, so let's take a quick look at the config toml for the video drone. So our source is going to be a UDP stream that we're going to capture through the FF-MPEG support. That's part of OpenCV /GoCV /wasmVision. We're going to use the CUDA support. And for our data storage, we're going to use BoltDB, which is a very high-speed key value local store that uses a single file. It is to key value stores like SQLite is to SQL, perhaps. It's used in the Kubernetes native store for configuration settings and some other things. So our pipeline, we're going to use face detect, YN, the face counter, and face blur. And then our configuration, we're going to tell the face detector to not draw faces. That way we don't end up with extra squares around faces that are then blurred. Yeah. Because we just want to have them basically blurred. So let's take a look at the face detect YM processor. This is, again, very similar to the equivalent OpenCV code that you would see, or GoCV code. But again, it's a bit simplified. All right, we process the image, we load our configuration, we set the input size of the detector to whatever that image size is, and then we do the detection for whatever faces we can find, and then handle faces takes, and if we were going to draw the faces, it would draw them, but we're not going to do that here. Instead, we're just going to store that facial data to our data store so that one of the processors downstream can then do the blurring. The face counter doesn't actually have to do any computer vision-y stuff at all. It just has to take that data and, based on the number of faces that were found, store that into our data store. Basically, it says every second, count the number of faces and then store that. That way we can see how many people did it see. And then last, the face blur processor. This kind of combines both of them. It says, let me get that data of the faces to be blurred, and then for each one of them, take and blur only that image area, and then save that and display that at the end to our output. So it should blur all of our images. Then the drone itself, the drone is written in normal Go. It's a separate application. And our main function, first we go start joystick, which is going to start the joystick in a separate Go routine for concurrency, and then start the drone itself. And if we take a look at the joystick is basically reading my joystick and looking at the different buttons. Let's see, triangle is takeoff, X is land. Then the joysticks, the right stick controls forward and back. The left stick is right and left. Okay, that's enough to fly it, right? Oh, wait, there is one other thing that's kind of important. The video itself, how it actually gets into the... So the video is streamed from the drone, and because the GoBot package receives those frames and strips off the first 2 bytes and then just republishes them on the proxy in Go. This is part of the built-in Go net package. Go's got really good networking support, and it's got really good concurrency. So we can actually keep up pretty well with the video stream, though every time we receive a video frame, we just write it to the proxy. So it's basically acting as a little proxy. All right, here we go. Turn on the drone. The drone is on. It's booting up. Plug in the joystick. I'm plugging in the joystick, because that's always a good idea. We need control. Let's see. All right, connect to the drone through the Wi-Fi. Let's see. We have to turn on the Wi-Fi. And then connect to... It should appear. It's a separate access point. So we connect to the tele. All right. So now, first we start the drone. Okay, we're connected. Then we start the stream. Never mind these error messages. Those are coming from... All right, so there's the drone. So let's put it down. This is why I had to move to a different spot than my normal office, just because otherwise I couldn't fly it. I just didn't have enough room. All right.
Ah, the noise of the whine of a drone.
That's why it's called a drone.
Yeah. Funny how that works out. Oh, cool.
Oh, okay, nice.
Here I am.
Yeah.
It works really well with the CUDA support. when there's a lot of people in the front row.
Now, is this algorithm also calling you old, or?
No, it's theoretically targeting me,
Yeah,
but
it's preserving his privacy. So
anonymously though.
yeah.
I couldn't get anybody else to agree to show up for this. Let's see if there's anybody outside. No.
The stability is really impressive here.
Yeah.
Well, that's the thing. Go. It's pretty good language. You should check it out.
Turns out.
Yeah.
All right. Let's land this because I've definitely pushed my limit as far as like what we can do, safely. Oh, yeah. It landed. Oh, all right. We made it. Incredible.
All right. That was impressive.
Yeah. Super fun demo.
So, was that fun?
Oh, it
Yeah,
was. Yes.
it was.
So, wasmVision version 0.5 is coming very, very soon. It's got some pretty interesting new capabilities, in particular related to its MCP support. The Model Context Protocol is a protocol that a lot of machine learning systems are using in order to call
Super
tools.
hot these days. Yeah, our friends at Rerun just released MCP support as well.
Yeah, wasmVision's had MCP support for a while, but we're beefing it up quite a bit with this new release, as well as some other exciting things that I will only unveil at my keynote coming up in less than 2 weeks at the GoLab/RustLab conference in Florence, Italy. So,
right on.
So you'll have to wait until that for the big reveal. But yeah, wasmVision.com. It's all open source. It's available now. It works surprisingly well for a not 1.0 piece of software, largely because it's based on OpenCV, which is certainly the gold standard for computer vision, and GoCV, which is a project that has got a lot of people using it in production as a way of putting computer vision applications out into the real world and making them do important things. So I thank you very much for having me on. I really appreciate it and getting a chance to talk to you. And please feel free to reach out if any of this is stuff I can help you with.
Yeah, thanks for joining us here. I'll bring back everybody up on camera here. We got a couple more questions before we go. We go home here today. Over on our trivia winner, in fact, Flavia asked, will Ron provide a link so we can run the examples shown today? We'll drop those in the show notes over on YouTube to all the GitHub and the other examples here.
Yes, absolutely.
Okay, fantastic. We've also got earlier in the episode, Home Slice on YouTube said, geez, green shirt guy, button up your shirt, please. Absolutely not. Do not tell me what to do.
Green shirt.
Over
I was actually thinking that was a really cool T-shirt, but
over on LinkedIn, we've got a more in-depth question here. Dr. Rahul Sharma asks a suggestion or approach for landscape segmentation on a drone camera, and I think perhaps GoCV is a good tool for this. Have you seen people doing this with GoCV, Ron?
Yes. A couple of different ways. There are already several different models for image segmentation, which might be able to work out of the box. If you go and you take a look at some of the models, everything's now on Hugging Face from the OpenCV Onyx models. And then there's also a separate set of models that was originally part of a different, I guess, the Onyx Foundation, or anyway, I probably have the name wrong, but those are just two. That certainly would be a good approach for something that you could do that could actually execute in the drone itself. If the flying thing is an embedded Linux, if it's connected to a ground station, you have a few more options. There's actually a lot of interesting work going on with vision language models, as I mentioned earlier with the Olama. Captioning is one. But there's a lot of other ones that are, basically fine-tuning models on different landscapes that match your input data of whatever it is you're looking for. I think that there's a lot of zero-shot segmentation models that could maybe do it, meaning ones that don't require any training or fine-tuning. And then separately, maybe with a modicum of fine-tuning, you might be able to take that and then shrink it down a lot smaller, so maybe it could execute on your embedded Linux. Maybe I'm telling people too much about the thing that might be coming out in a couple of weeks.
Dun, dun, dun. Thank you for that. This one's not a comment, just I liked this, or it's not a question, it's just a comment. I like this one. Carlos on Zoom. I think this webinar just serendipitously answered my problems.
By creating new ones.
Yeah.
Well, you were born to those problems.
It turns out. Yeah, computers were a mistake, and we just keep making it worse. Anthony over on YouTube asks, is the CUDA acceleration available in, I believe that this was about GoCV, to be able to stream live video, and so video encoding like HLS or H.264?
Because of the FFmpeg support, I think you have a very good probability of supporting some of the streaming formats that it can decode. If not, you have the GStreamer support, but that's a lot harder to work with. I'm not going to lie. I've used GStreamer a bunch. Every time I feel like I know nothing about it, but it does everything if you could just figure out how to make it work. So yes, you can. There's a lot of standard formats that are supported by OpenCV, and as a consequence, GoCV. Oh, but wait, CUDA acceleration. I think the answer to that is it depends, because it might be supported as a part of your operating system, but it might not. There is a CUDA package for OpenCV for video input and output that is not yet supported by GoCV, but it could be. It's a little trickier trying to get that to actually work on many different platforms, just because it's a bit more hardware specific.
Yeah, well, and like on the Mac, for example, you'd be using Video Toolbox instead, right? Yeah. Thanks for that. Another comment here from Home Slice says, agree with Ron, but Python is still one of my go-to languages for quick development. I think that we're all pretty agreed on that one there. That's what Python's really powerful for.
I use Python every week.
Yeah.
Every single week.
Yeah. Me too. Yeah, I can't think. Probably in the last 15 years, I don't think maybe 3 days have gone by where I haven't written some Python.
But I generally do not deploy Python to production.
Another comment from one of our friends on Twitch, Totally78, one of our Twitch followers. Great topics again today. Love to see alternative frameworks, languages, and patterns. Thanks. Really
I am here for you, my friends.
Yes, indeed. We got one last question here from Sachin on YouTube. How can I get started with the Go programming language? I don't have any experience in Python either. You got any good suggestions for how to get started with Go, Ron?
I really do. Go, the community of Go is very interested and helpful. One of the things about Go is try Go. The Go playground, which is if you go to go.dev, you will find right away a link to the Go playground and the tour of Go. TinyGo also has copied this same sort of idea. If you go to tinygo.org, our website, you will find right on the homepage, if you scroll down a bit, a live simulator of programming Go on actual hardware. And then there's a whole tour that we're constantly adding to with support for controlling different types of hardware interfaces, I2C, analog, GPIO, and the like. So there's a lot of great resources right there. And then, of course, there's a lot of amazing content that's available. I would have to recommend my friend Bill Kennedy's Ultimate Go courses. They're really, really awesome, really, really in-depth. You can also get that on video. And there's a lot of other amazing books and resources and videos. So try Go. You know, we're friendly folks.
Go, won't you? Yes. So I think we're about half past the hour here. I think Satya, you want to send us home?
Yeah, thank you, everybody. Thanks for being here every week with us. It's really very important for us to connect with the community, and this is our way. And thank you, Ron, for this amazing presentation. I really enjoyed, and the live demos, all of them succeeded, which is sometimes difficult to pull off. And they were all involved demos. And thanks for also educating the community about Go as well as Wasm. So really enjoyed the show. Thank you so much. And finally, thank you, Phil, for organizing this show. Nothing went wrong. Thank you so much. And last but not the least, thank you all to the entire community. Thanks.
That's right. Hey, there's still time for something to go wrong, Satya. But no, thank you so much for watching, everybody. We really appreciate you. We will be back next week, same bat time, same bat channel, 9 a.m. Pacific time on Thursday. It's going to be another fun one. We have SLAM Algorithms Part 2. We had a lot of fun talking with our friend from Slambotics about 6, I believe, of the current SLAM algorithms out there. We're going to take a look at 6 more of them next week. And so look forward to that at all the usual places you watch us: YouTube, Twitch, LinkedIn Live, and on Zoom. Take care of yourselves out there, folks, and take care of somebody else if you can. Have a great day wherever you may be.